Here we are looking at change point indicators. To continue on from previous videos on extreme value theory, it is good to know extreme values for effective risk management, but it is better to predict them with a certain amount of certainty.
We download SPY data from QuantMod, convert the R-metric time series data for charts on histogram and boxplot, and then load performance analytics library for 4 histogram grids. Lastly, calculate conditional and we load this data to get these charts. That's the SPY chart. That's the histogram of the SPY. SPY is S&P 500 ETF index. It's an exchange traded fund on the S&P 500. That's the box plot. And you can see that there's a lot of outlying data on the box plot, especially near the variance at risk, which is about there. Between there and there's a lot of data. So yeah, not so much extreme movement. But it's only a 3-year. And that shows the variance at risk, modified and empirical variance at risk plus modified variance at risk. They're very close on daily data. If you separate into monthly or quarterly, you can see the biggest spread between them. You can see the extreme cases compared to the normal curve here, and that's shown more in these next charts. The curve fitted over 0.3. You can see its kurtosis is way above that of the normal curve. It's not normal. It has a way better tail. And once again, the skewness of kurtosis is shown there. There is a lot more data to the minus side than on the positive side. It is skewed to the left, and it is highly kurtotic. Leptokurtic, as you say. And there's the risk measures again. So we'll just close that. Now we'll move on. And that's a frequency table. I won't calculate that again. I calculate it using that, break it into a Sturgis classes, into a data frame table, and with a table I transform into relative frequencies. I'm actually printing it out in table format. It looks neater. Got so many noughts. And the extreme downside data is minus 11%, 11.6% to minus 9.75%. So that's significant. And you can see that the median of 628 events, or 63% of data, is captured from 0.113 down to 0.116. So yeah, there's more downside than upside. From there, there's only not much happening. There was 10%, 0.05, 0.05, 0.02. 63% of the data is downside, except for a small amount in the 0.01% error change per day, which could be significant. It could be a lot. So maybe half of that 628 is on the upside, maybe half on the downside. It's hard to say. If you look at the chart, it's slightly skewed. And which moves on to the next bit where we look at the ECP library. Now this library really is very intensive on your processor. Now I got a new computer with a new generation 12i7 chip.
The ECP library is a collection of extreme change point indicators. It takes, as mentioned, a while to run on processors less than i7 capability. It is a crash metrics indicator. Unlike the next library, we run BCP, which measures the Bayesian likelihood of a change in underlying drift and shows far more turning points than extreme crashes. They both have their place in your toolset.
For reference to the actual commands, it's quite a difficult thing to program, eDivisive. I came across this 199. There's actually 250 days in a year, but I found that it wasn't actually 100. Like the amount of data was taken from not 3 full years. So 199 accurately reflected conditions. You have to muck around with that. The minimum size is 30, and it calculates automatically, and it's a very intensive algorithm. Now, I'll run it again just to show you how long it takes for a power. Still calculating. It just stopped. So it took 30 seconds or a minute. It can take 15 or 30 minutes. Slot machines, maybe even longer. You've got a lot of data. It can take hours. That's why I limited my data to 3 years. When I first did it, it took half an hour, I think 15 minutes to run 2002. I think 2020. But it did pick all the breaks, all the extreme changes. And we can go through and we can see that it's picked extreme changes. Let's see, what have we got here? Extreme change points, it picked the data. The data was, the last change point it picks is actually the last bit of data. So it's n-1. 288 days from January 2019, 319 days and 733 days. What that comes out in days was a few days before the crash, it notified you of an impending doom. A few days before quantitative easing kicked in and went berserk, it notified you of another violent jump. And in 2021, before the problems this year, it notified you that the means were shifting and there was large variances coming. We'll look at the chart. And we'll just go over to the chart here. And you can see it on the chart. Oops. Oops. What's going wrong here? Oh, I have to run that again. It doesn't run on the other one. That's a quirk, markdown on my computers. I haven't quite mastered it. It ran at first, but then after a while it doesn't run. So I'll run the chart. We got the data. It should run. Oh. And you can see that was the big crash in 2007. The notification was probably a week before, and that was on the just after the first big quant leaps up. It picked a break there, the next biggest quant leap about the same time. So it actually missed the upside a fair bit, picked the downside, but it was a warning, and it warned again later that year, this year, in 2011, in 2021 on the 11th month. If you see there, you can see that volatility has erupted. There was a warning there, the volatility was about to erupt. And that can be shown in the chart. I think it can be shown in the chart. Where's the chart? Oh, chart here. This chart. If we look, we'll expand it. Oops. If you can see about the 11th month, about there. You can see before the dramatic downturn it notified us. So it's a pretty effective warning system. Now the next one, the Bayesian change point process, is a lot more sensitive and shows a lot more changes. It doesn't pick extremes. It warns you of breaks in the underlying structure. We'll go down to the BCP library. Let's see if we've got here. Just run that. I don't need to run the update. And you see the means and probabilities of change. That's the means, and that's the fitted data. And you can see that there's extreme warning, almost a 90% warning there, and there's been lots of extreme warnings here. It's not a safe time to be trading at the moment. Calming down a bit now, but then again it could just jerk up again. As you can see, it's been a troubled time since 2020. Close that. And that's a correlation test data about these things. I'll just show the libraries. DataCamp has online libraries for them, and they cross-reference to the CRAN references, PDFs. That's ECP. That's the one I use, eDivisive. And they'll give you a description and some code, and that's the BCP package. BCP is an R package that provides an implementation of the Barry and Hartigan 1993 product partition model for the normal errors change point problem using Markov chain Monte Carlo. It also extends the methodology to regression models on a connected graph. It allows the estimation of change point models with multivariate responses. BCP library, and we'll read the ECP. ECP implements various procedures for finding multiple change points from Madison D. et al. 2013, Zhang W. et al. 2017, and Arlett S. et al. 2019. Two methods make use of dynamic programming and pruning with no distributional assumptions other than the existence of certain absolute moments in one method. Hierarchical and exact search methods are included. All methods return the set of estimated change points as well as other summary information. And I'll just quickly show you that in my archive. Where is it? Summary out will give you they're all the statistics you can find. It brings the k-hat, the order found, the estimates, considered last, p-values, permutations, cluster. And when you got those, that's the actual day of the error of the extreme event. Now you can just go down to here and DR SPY 288 from the data, and that'll bring up the date. The 2nd of the 24th, 2020, a week before the extreme crash, and the data that day was 3.3% down. So you get that. And the BCP is different in the sense that it is a BCP. I don't have it at the moment. Let's see if I got it here. BCP. There's more stuff there. A lot more charts which I didn't include. BCP is generally, you just put the data in the plots, and the plot gives you what you need to know. The plot gives you the probabilities. You can see where the data is, and it'll show there's a warning there of almost posterior probability of almost 0.8%. So it's a warning. When it's down around here,
I'm sure glad that's over with.